Apache's Corner, we're going to look at solving rational equations and inequalities, and this is our second day. Okay, today we're going to start with inequalities. We're going to go off the basis of the equations that we worked on in our first day. So the first thing we have to do when we see an inequality sign is we're going to have to create a related equation. So we're just going to rewrite this. I'm going to make that a -1 like I have in the past, just so we don't lose it. And I'm just going to change that inequality sign to an equal sign. Okay, I'm going to find our LCD, which in this case is 12 times x minus 2. And I'm actually going to solve this as I have in the past. Okay, so we're going to set it all up. We're going to multiply each fraction. We're going to multiply each fraction by our LCD, and then we're going to simplify where we can. Again, a lot of writing to get us started. Okay, and then we're going to cancel what we can here. So this 3 goes into 12 4 times. And then I'm left with 4x squared minus 8x. This is going to simplify minus 12. That's what we get, a minus 12 there. And then on the right side of our equal sign, this will simplify. And then we are left with 3x plus 3. If I multiply this 3 times x plus 1 times x minus 2. So we're going to have to do a little work on that. All right, so left-hand side can stay the same. And now we'll use FOIL on the right-hand side. So I get 3x squared. Outside is negative 6x. Inside is positive 3x. And the last is negative 6. So in the end, this combines to negative 3x. So again, I have to bring everything to the left-hand side to see if I can factor. So I'm going to bring this negative 3x to the other side. And I'll add 3x to both sides. And I'll add 6 to both sides. And I'm left with x squared minus 5x minus 6 is equal to 0. All right, so I'll factor x and x. I have a plus and a minus. My 6 goes here, my 1 goes there. So I know that x is equal to -1 and positive 6. Okay, so now we need to figure out what is going to work within this inequality. So we don't know if all values are going to work or just some values are going to work. So this is where things get a little different. Okay, so we know that we're going to use our number line. We know we need a spot for -1 and 6 because they're the values that we received as an answer. I also know if I look at my original inequality, I know that I have x minus 2 as my denominator. I know my denominator cannot be 0. So the other value I'm going to work there is 2. 2 minus 2 gives me 0. So it's going to be my other value is going to be 2. Now I have this number line is now broken up into 4 sections or regions. 1, 2, 3, 4. So what I have to do is I have to test each region. So I'm going to pick a value from each region and see if it works. So I'll do the first one with you slowly. X is equal to -2 for my first region here. And I'm going to substitute that back in. So I end up with -2 thirds. And again, I'm doing it into my original inequality. Plus 1/4 is less than -1/4. You're going to use your calculator. That is true. That's a true statement. Okay. So this is going to be a check. That region works. I'm going to do it for each of them. X is equal to between -1 and 2. We'll do x is equal to 1. When I substitute that in, again, you can try this, pause this video, you can try it. I have 1/3 plus 1/1 is less than 2/4, and that's false. So that region is not going to work. Do the same thing between 2 and 6. I pick x is equal to 3. Again, substitute your values in. I do 3/3 minus 1/1 is less than 4/4. And again, that's true. So that region will work. Do the same thing where x is equal to 7. My last region, 7/3 minus 1/5 is less than 8/4. That's false. So that doesn't work. So then when I'm done, I look at all the regions I have and what works. So what I can say is x is less than -1. And I also know that I'm between 2 and 6, or 2 is less than x, which is less than 6. So x is between 2 and 6. So there are our final regions of inequalities that will make a true statement in our given inequality. All right, let's take a look at number 2. Now, if you want to try this one by yourself, you're always welcome to just pause the video and see how you do. Okay, so I'm going to first do my related equation. Oh, that's supposed to be an equal sign over 9. My LCD here is going to be 9x. So I'm going to multiply everything by 9x, each fraction. See what I can simplify. So this gives me 12. My x's will simplify here, and I get plus 63. And the right-hand side, I get 5x. And it gives me 75 is equal to 5x. So x is equal to 15. Now, if I look back at my original, I know that I cannot have x cannot equal 0. So when I do my number line, I have to keep that in mind. So I'm going to have 0 as a value, and this x is equal to 15 as a value. And now I'm going to test my different regions, okay? So if I test x is equal to -1, now again, if you want to pause it, you can to work this out on your own, but I'll just write out what I have here. So I have 4 over -3 plus 7 over -1 is less than 5 over 9. So that's true. So this region right here is okay. All right, let's look at our next region between 0 and 15. Again, we can use any value you want. I just like to keep it simple. I'll use 1, and I ended up with 4/3 plus 7 over 1 is less than 5 over 9, so that's false. So that region is not going to work. Let's try our last region. I can do anything above 15. I'll just use 16 so I don't get too high. And I have 4 over 48 plus 7 over 16 is less than 5 over 9. And that one is also true. So our final answer is going to be our regions that work is that x has to be less than 0, right? It can't be equal to 0. Otherwise, we'll have a 0 in the denominator, which we can't have. Or x is going to be greater than 15. And that's your final answer right there. Now we're going to take a look at a word problem that is called a work problem because there is work involved. So every year, the junior and senior classes at Hillcrest High School build a float for the homecoming parade. If it takes the senior class 24 days to complete a float and 18 days, that's important if they work together with the junior class. How long will it take the junior class to complete a float if they work alone? All right, so we have our little setup here. We have time together over time alone plus time together over time alone will equal 1, meaning 1 full job. Okay, so we have our seniors and our juniors. So let's see what our setup is. It does take them 18 days to work together. So that's time together. Seniors, it takes them 24 days to work by themselves. Juniors, again, 18 days to work together. And we don't know how long it's going to take them to work by themselves. So it's going to be our variable is equal to 1. Now our LCD here is 24 times x. So I will multiply each of those fractions by 24x. To clean it up a little bit. That will simplify and I get 18x. My x is simplifying, that gives me plus 432 is equal to 24x. So if I try to isolate my variable, I'm left with 6x is equal to 432. So x is equal to 72. So this juniors really take a long time. So it will take the juniors 72 days to complete a float if they work alone. Okay, thanks so much for stopping by today. You have a great day.